Section 1.8, Perimeter, Circumference, and Area. The objectives for today are to find the perimeter or circumference and area of basic shapes. First of all, let's talk about the differences between perimeter and area. Perimeter is the sum of the lengths of all the sides. So for instance, if you were going to put a fence around your yard, it would be how much fence do you need? If you wanted to put trim board around the room, how much trim board would you need? Area is different in that it's the number of square units a polygon encloses. So when we go back to the room, if you wanted to carpet your room or put new flooring in, it's how much floor do you need? If you are looking at your yard that's fenced in, how much area is inside that fence? So they are two totally different things. Perimeter, you're going to label whatever the label is. With area, you're going to label it squared. So if it's inches, you're going to label inches squared. So make sure you have the labels correct. Here's a few formulas that you'll need, and you do not have to memorize them. They will be on a formula sheet that you can use. The only difference is the shapes will not be there, just the formulas will be. So let's look at a square first. The area of a square is side times side, or side squared. The perimeter of a square would be side plus side plus side plus side, or 4 times the length of the side. For a rectangle, area equals base times height, or length times width. The perimeter would be base plus height plus base plus height, or 2 times the length plus 2 times the width. Another formula would be 2 times the base plus 2 times the height, depending on the letters that you wanted to use. For a triangle, your area is half times base times height. Remember that the height is the vertical unit that you're looking at, the one that is on that line that makes a right angle. Sometimes that height can be inside the triangle. If it's an obtuse triangle, it could be outside. It doesn't necessarily mean that it's included. It just means that's what the height is. For perimeter of a triangle, since there's 3 sides, you would add up all the sides. Lastly, a circle is pi times radius squared. For circumference, it's 2 times pi times r, or pi times d. Let's talk about the differences there as well. So pi is about 3.14. That's what the book uses. You can use the pi key on your calculator. When you get your answers, if you're a 10th or 2 or a 100th off, that's probably why. The book uses exactly 3.14, where your calculator, if you use the pi key, it uses the full value going across your screen. Next, radius is halfway across, diameter is all the way across. So diameter is equal to 2 times your radius. That formula is not on the formula sheet. That would be something that you guys should know. Let's look at problem number 1. The Botany Club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside of the path. How much edging would they need? So when you're looking at this one, this is on page 60. They have the picture that represents, but they also have like just a little hand-drawn figure as well. So we'll do one of those. So they want edging, so we need to know the length around the whole thing. So when you were looking at this right here, this is 16, but how much is here and how much is there? Okay, so you look straight up and down and you see no numbers. But when you're looking at a rectangular garden that has a path going around it, since this up here is 4, that makes this distance right here also 4. And the same on the other side. So here's 4, there's 4, and then 16 altogether. So 16 plus 8 would be 24 feet. Okay, let's do the same thing going the other direction. You have 22 feet here we already figured out that on the top, this is 4, but also if it's a 4-foot path, it's the same on the top and the bottom. So here we have 22 plus 8, or 30 feet. How much edging? So when you're looking at it, edging is perimeter. So perimeter equals 2 times 24 plus 2 times 30. So your perimeter would be 48 plus 60, which is 108. Perimeter is labeled just whatever the unit is. Make sure that you are also showing your work, which would be your 2 times 24 plus 2 times 30. Here is the first got it question if you want to try it. You can pause and then come back and check your answer. You want to frame a picture that is 5 inches by 7 inches with a 1-inch wide frame. Okay, so we have a picture that is 7 inches by 5 inches. And then your frame goes around that. Okay, so I'm going to actually do that in a different color. Just give me a second here. Okay, so your frame goes around that, and it said it was 1 inch. So we have 1 inch here. We also have 1 inch there because it's the same going all the way around. So what's the perimeter of the picture? So perimeter of the picture would be 2 times 5 plus 2 times 7. So 10 plus 14, which is 24 inches. Okay, what is the perimeter of the outside edge of the frame? Well, remember we have a 1-inch frame, so it is 5 here plus another 1 plus another 1. So your new width is going to be 2 times 7. And then remember going the other way, this much right here is 7, plus you have another 1 and another 1. So we have 2 times 9. So 14 plus 18 is 32. And again, you would have to show your work, so I would want the numbers plugged into the formula and then give me your simplified answer. Moving on to circles. What's the circumference of the circle in terms of pi? That means they want pi in the answer. And then for B, what is the circumference of the circle to the nearest tenth, which is 1 decimal place. So when you're looking at the picture, the first thing you need to do is figure out what formula you're going to use. Since we're talking about circumference, we can do 2 pi r or pi times d, whichever they have given you. Now in the picture, since they have given you the distance all the way across, it actually is your d. So here, 15 is equal to d. If you wanted to use the radius, you would take that and divide it by 2. So your radius would be 15 divided by 2, or 7.5. And then you could choose which formula that you wanted to use. So since they gave us d, let's do circumference equals 15 pi, and that is your answer. We'll label it with inches. Okay. Make sure again that you're putting your numbers into the formula first and then actually calculating after that. What is the circumference then? Circumference would be 15 times pi, and you'll actually calculate that. If I use the full value for pi on my calculator, I get about 47.1, and that would be inches. I need the formula with the answer. If you use just 3.14, your value would be the same. So 15 times 3.14 also gives you 47.1. Those two little squiggly lines are approximately equal to, since we are rounding. I don't care if you use the full value for pi on your calculator or if you estimate using 3.14, they're going to be close enough. As long as you give me the formula with your numbers plugged in and the answer, I'll be able to figure it out. Problem number 3 is on the bottom of page 61. What is the perimeter of triangle EFG? So we need to know the lengths of all these sides. All right, so I'm going to do EF first. And since it's a straight vertical line, I'm going to count the squares. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so EF equals 8. GF is another horizontal line. So anything that's straight vertical or straight horizontal, you can count the squares. 1, 2, 3, 4, 5, 6. Now, the problem with GE is that it's slanted. Anytime there's a line that's slanted, you have to use the Pythagorean theorem. So we are looking at a triangle that now looks like this. We don't know this one. I'll call it X. The bottom side is 6, and the other side is 8. So 6 squared plus 8 squared equals X squared. You could also plug the ordered pairs into the distance formula that we learned yesterday, but that takes a little bit longer, and sometimes people get their signs wrong. So 6 squared is 36, 8 squared is 64. If we add those together, we get 100, and then you'd have to square root both sides. Now, X is going to be just positive 10 because we can't have negative length. So EG is 10. Now we put that all together and find perimeter. So we have 8 plus 6 plus 10, and our perimeter would be 24 units. Usually if it's on graph paper, I don't usually count it wrong if you don't have a label. The book will use units here. Problem number 4, you want to make a rectangular banner similar to the one below. The banner is 2.5 feet wide and 5 feet high. So 2.5 feet wide and 5 feet high. To the nearest square yard, okay, notice the label change there. How much material do you need? You can try this one on your own and come back and check if you'd like. This one is on the top of page 62. So the first thing we're going to do is we're going to convert feet into yards originally, because most people have trouble converting it at the end. So when you convert 5 feet to yards, there are 3 feet in 1 yard. Okay, the feet cancels, so we have 5/3 yard. We'll do the same thing with the 2.5. So 2.5 feet converted into yards would be 2.5 divided by 3, which is 5/6 yard. Okay, so now we've converted to yards, and we want to know how much material that we're going to use. So it's not the framer on the outside, it's the actual material. So we're going to take and multiply these two numbers because we want to find area. 5/3 times 5/6 would be 25/18. And I'm going to go to the nearest square yard. So 25 divided by 18 is 1.38 or 1.39. You can't go to the store necessarily and get 1.39 yards. So we're going to need to round that up to 2 square yards of material. You'll have a little extra, but at least you'll have enough. Problem number 5. What's the area of the circle in terms of pi? First, what you want to look at is the 16, the radius or the diameter. It's the diameter because it goes all the way across. So if we use our formula for area of a circle, we get pi times radius squared. So that means we do need to know what the radius is. I'm going to take 16 and divide it by 2, which is 8. So putting that into our formula, pi times 8 squared. When they say in terms of pi, leave the pi in your answer. So we get 64 pi meters squared since it is area. The two things I'm looking for are, do you have the numbers plugged into the formula, and do you have your answer in the terms that they wanted? Postulate 110, make sure you guys put this into your postulates and theorems. So add that to your postulates. Postulate 110 says the area of a region is the sum of the areas of the non-overlapping parts. So in problem number 6, which is on page 63, what is the area of the figure below? So when you look at that, we see a staircase, but when you look at your formulas that we learned, we had the area of a circle, the area of a triangle, the area of a square, and the area of a rectangle. A staircase doesn't fit any of those. So what you're going to do is you're going to break it up into those formulas that we know, whether it be rectangles or squares or half circles or circles, and then you're going to add them all together. So there's a few different ways that you can do this. You can go like this, and then you're going to have 3 areas added together. The top one we'll call area 1, the middle one we'll call area 2, the bottom we'll call area 3. Once we've found those areas, we'll add them together. So you have to pay attention to all the hash marks. The doubles are 9. The singles are 3. So I'm going to put all of those in so we can see them all. Now let's focus on area 1. Since we are looking for area, it is length times width or base times height. So we look at 3 squared. So area 1 is 9. Area 2. We don't know the length at the bottom, but we do know that the height is 3. It is not 9 because 9 is the whole entire side. We need to know how much is this right here. So if it's 9 all the way across, 9 across the bottom, and this much right here is 3, the bottom side of area 2 would be 6. The height would be 3. So we would get a total area of section 2 to be 18. Area 3 is that bottom piece. It's 9 all the way across the bottom and 3 high, which would be 27. And then we will add all those numbers together. 9 plus 18 plus 27 is 54 centimeters squared. So the total area is 54. Do not just give me the final answer. I need all of the work that you did to get to that answer, and that's how it will be graded on the quiz tomorrow as well. That's all I have. Bring questions on Thursday, and we can get those answered before you take the quiz on Friday.